So section 10.6 is going to be about secants, which is a new vocabulary word, tangents, and angle measures. So we have one more vocabulary word, which is a secant. And a secant is kind of like a tangent because it is a line or a piece of a line, but it's going to intersect the circle in exactly 2 points. So it's kind of like a tangent in the fact that it's a line, but it's kind of like a chord because it's going to hit in 2 points. So let me show you what this is going to look like. So if you draw a circle and you make a chord is a segment, but then if you turn that chord into a line instead of a segment, then it's what's called a secant. So we would name this secant line AB, and the chord would be segment AB. So keep in mind the chord is the middle part of a secant, but the secant is the entire line. All right, so when two secants intersect inside a circle, the angles formed are going to have a relationship to the arcs that are intercepted. And by intercepted, that just means cut off from the rest of the circle. So let's look at the first theorem. So this can happen even if you have two secants or two chords. It doesn't matter if they are lines or they're segments. This is going to work the same either way. What it says is the measure of the angle formed that's inside the circle is going to be half the sum of the arcs that are intercepted by the angle and its vertical angle. It sounds really hard, but let me show you what happens. So if I want to find angle 1, I look at the arc that's intercepted, which is AB, and then I come over here to the vertical angle 1, and I look at the arc that's intercepted, which is DC. And if I add AB and DC together and take half, then I'll get angle 1. Well, if I wanted to find angle 2, then what I would do is if I were looking at angle 2, arc BC is the one that is intercepted, and over here the vertical with 2 would be over there, and this would be arc AD. So if I wanted to find angle 2, I would add BC and AD's arcs and then take half. Now keep in mind you wouldn't have to do both formulas because these are a linear pair. So once you find one of them, then you can just do a linear pair to get the other. So I'm going to show you two examples of how this theorem works. So notice that these are two chords that are intersecting inside the circle. So my vertex is inside the circle. All right, now I'm going to look at X, and then I'm going to put the vertical X over here. Those are vertical angles. And then I'm going to look and notice that these are the arcs that are in line or intercepted from X. So if I have angle X and I extend it, this arc 130 is intercepted, and then this arc 84 is intercepted over here. So I'm going to take my formula, and I'm going to say X equals 1/2 the sum of the two arcs. So I'm just going to add 84 plus 130, and then I'm going to take half of that. So X is going to end up being 107 degrees. Okay, so now if I go over here to letter B, this one's going to be very similar, but notice that that X is not in line with these arcs. This X and this vertical X, they both intercept these arcs. So I don't want to use that X right away because I don't have the arcs that are there. Now, could I find them? I could see what they sum to, but instead I'm going to use a different technique. I'm going to make this angle Y and this angle Y, and I'm going to use the Y's, and then I'll do a linear pair. So notice angle Y cuts off arc 75, and over here the vertical angle Y cuts off 143. All right, so if I wanted to find Y, I would do 1/2 the sum of the intercepted arcs. So I'm going to add up 143 plus 75, and then I'm going to take half. So that's going to give me a 109 for this angle right here, and its vertical would be 109. Now to find X, these are a linear pair, or these are a linear pair. So to get X, I'm going to take 180 minus 109, and my X is going to end up being 71 degrees. So I end up using the angle that's in line with the arcs, and then after I find that, I do a linear pair. So that one has one extra step that this one didn't. Okay, so you are going to need to try these. I know that you are going to want to skip them and not do them, but you need to, after the video's off, try these 3 and then check them with the online key to make sure that you're doing them correctly. Okay, so down here we are going to look at a second theorem. So notice that if I go back up here, my vertex of my angle is inside the circle. Now I'm going to come down here, and my vertex of my angle is going to be on the circle. So this is going to have to do kind of like what we talked about when we had an inscribed angle. So recall that an inscribed angle, if you have an inscribed angle, it's half the intercepted arc. So just to review that, if my arc was 50 degrees here, this inscribed angle that's on the circle would be 25 degrees. Now, these are not going to create inscribed angles. In fact, it's a secant and a tangent. So here is my secant, and notice it's not an entire secant. This is just part of a secant, which is fine. It has a ray on it. And then this is my tangent. So when my secant and my tangent intersect, then it works like an inscribed angle. It's going to be half the arc. So let's look at what this has. Angle 1 is on the circle, just like an inscribed angle. So it is going to be half of this arc. So if this was 100, then angle 1 would be 50 degrees. All right, and then likewise, if I come over here to the other side of the circle, if I wanted to find angle 2, that would be half of this arc that it cuts off. So in this case, it would have to be 260 to make a whole circle. So then this angle would be 130. Notice that those are still a linear pair. They're still going to add up to 180, and then my circle has to add up to 360. Okay, and again, this vertex is on the circle instead of the one at the top, which was inside the circle. All right, so if you flip the page over, we're going to look at 2 examples, and then you'll try 2 on your own. All right, so when you see a tangent and a piece of a secant, so this is like part of a secant. I mean, I could extend it out and make the whole secant if I wanted. That vertex is on the circle. Okay, so if the vertex is on the circle, then I know that that angle is half the arc that's cut off. So if that arc from P to R is 148, then I'm going to take half of that and I'm going to get an angle. So I'm going to get my angle that's on the circle. I'm looking for QPR, which is this angle. So it works like an inscribed angle. Even though it's not inscribed, I still take 148 and I divide it by 2, and I get 74 degrees. So to find an angle that's on the circle, if it's inscribed or made from a secant and a tangent, you still take half the arc. Okay, so let's come over here to this other example. We would like the arc DEF. Okay, so DEF is all of this. So when I look at this, this angle is on the circle, so that angle is half the arc. So this angle right here is 64. That's going to make this arc 128, and I got that by taking 64 times 2. Now, my entire circle needs to add up to 360, so I will be taking 360 minus 128, and that will give me the remaining piece of that arc, which is going to be 232. So arc DEF will be 232 degrees. Okay, again, I need you to try these. I'm trying not to make this video super long, but I'm trusting that you'll go back and try these so that you can see if you get them, just to make the video a little bit shorter. Okay, so let's go down to one other type where you have secants with tangents, and these are going to meet outside the circle. So now we have ones that meet on the circle, inside the circle, and now they meet outside the circle. So the measure of the angle formed is going to have to do with half of the difference, and so we'll go through that. So if you have 2 secants, these are both secants or pieces of secants. I mean, you could extend them and make them full secants. Or if you have a secant and a tangent, so this is a secant and a tangent, or if you have 2 tangents, then you can use this theorem. And notice that the vertex on each one is outside the circle. Okay, the formula is this. To get your angle, you're going to take 1/2 of the difference of the arcs. Okay, so difference is subtraction. So unlike what we did in the last theorem, you're going to be subtracting and not adding. So let me show you how this works. To get angle A, which is out here, we're going to take 1/2 of this arc that was intercepted minus this arc that's intercepted. So it's the 2 arcs that are inside the secants. So this minus this, and take half. All right, what if it's a secant and a tangent? Works the same way. We still are going to take half the difference of the 2 arcs that are inside the secant and the tangent. So we take the big one minus the little one, and we take half. And notice that the big one needs to be first, or you'll get a negative. Okay, and if it's two tangents, you're still going to take the big arc, which would be BDC, you're going to minus off the small arc, BC, and you'll take half. And that's because the angle is now outside the circle. All right, so I'm going to show you two examples of these. So this angle L is outside the circle, and we would like to find it. So what you might notice is from H to K is 102. So I need to know what this big arc is out here so that I can use this formula. So to do that, I'm going to take 360 and I'm going to minus 102, and I'm going to get 258. So this big arc right here is 258. Okay, now the formula is the angle on the outside is equal to half the difference. So I make sure that I do the big one first and then I minus the little one, otherwise I'll get a negative answer. Okay, so you're going to take half of 156 when you subtract those, and you're going to get an angle of 78 degrees. So one thing that can happen is sometimes they will have you go backwards, and we've been going backwards this chapter, so you're going to use your algebra to go backwards. So what I'll do is I've got a 95 here. I don't know what this arc is, but I'll put an X on it. Notice that my angle is outside the circle. So what I'm going to do is I'm going to set up my formula, angle equals 1/2, and I'm going to go arc minus arc. Now I'm going to fill in what I know. My angle, I already know it, is 56. I still have my half. My big arc, I don't know it. I'm going to put an X, and I'm going to minus off the little arc, which is BC, which is 95. Okay, now I have to solve this in order to find X. So what I normally do to solve this is I times by 2 to move the 1/2 to the other side. And so I'm going to get 112 equals X minus 95. So the 1/2 I multiplied by the reciprocal to move it, and then I'll just add the 95 over. So the measure of arc CD is going to end up being 207 when I add the 112 plus the 95. And that's what I do if my angle is outside the circle. Okay, so here are two more U-tries, and again, I need you to try these because these are not necessarily easy, and if you skip them, you may not have any idea how to solve using these different theorems. So to make the video shorter, please go back and do those. All right, here is a summary, and this is also in your textbook. So this summary tells you if your angle is on the circle, inside the circle, or outside the circle. So I'm just going to recap with you. If your angle is on the circle, you take half the arc that is cut off. So it would be half of X in each of these cases. If your angle is inside the circle, but not at the center, keep in mind these aren't central angles, they're just inside, then you take the two arcs that are in line with the angle, you add them and take half. If your angle is outside the circle, then it's the same kind of thing as inside, but instead of adding and taking half, you're going to subtract and take half. Just make sure you're doing the big arc minus the little arc each time, or you'll get a negative number. On the very back of this sheet are some terms that I would like you to practice and see if you can list as many as possible for these different terms for your chapter so far. These will just go over the vocab with you, and we will check these in class to make sure that you have the correct vocab.